answers to the homework that was given. I hope everybody got a chance to do that. So question A is the one that's in purple. So we were given sine 40 cos 40 over sine 100. So we would have kept sine 40 and cos 40 in the numerator as is. And at the bottom, we would have used reduction formulae. So 180 minus 80 to get 100. And that would have reduced to positive sine 80 because we were working in the second quadrant. We note that 40 is half of 80 or 80 is double 40. So this becomes a sine double angle. And then we can cancel sine 40 cos 40 at the top with sine 40 cos 40 at the bottom. And we are left with a half or 1/2. How did that go? Was that okay? Any questions? Yes. Oh, good. Nolwazi's doing thumbs up. Siam Tanda says yes. Nopasutu says yes. Good stuff. Okay, we'll go and have a look at question C now. And Boichepo and Lokomelo. Well done, guys. You know, to still be so tired and fed up and end of term or holidays and you're still doing your homework is really awesome. Well done. Thanks, Lisa. That's great. Okay, then I also asked you to do question C. So that's the one in the sort of purpley pink against the margin. So 2 sine 75. Oh, then it was cos 255. Sorry, I didn't write down the question. I was naughty. I just went straight to reducing it. So 255 is the third quadrant. So it would reduce 2 times negative cos 75. And then I just brought the negative to the front because when you multiply a positive with a negative, it's negative. And then I just wrote it in the order of the identity. So negative 2 sine 75 cos 75. That is a sine double angle. So we write that as sine 150, but remembering it's negative, that reduces to sine 30. It's still negative. And we know that sine 30 is a half. So the final answer is minus 1/2. How did that go? Was that okay? Was question C okay? Any questions? Okay, Siam Tanda says yes. Any questions about C, guys? Oh, okay. No worry. That's okay. Yes, all right, that's fine. Okay. Question E is a question, it's one of those sorts of questions, in my opinion, and again, it's just my opinion, it's one of those questions that's so easy, it's difficult. There's really nothing that you can do here. There's no identity that you can apply or anything like that. The only thing that you can do is sub in for sine 30. So we would write 1 minus 4, and then the sine of 30 is a half, which we need to square. And then when we square a half, we get a quarter. So 4 times a quarter would leave us with 1, and 1 minus 1 would leave us with 0 as an answer. How did question E go? Was that fine? Are we all smiling still? Yes, Sharon. Unmute yourself and ask.
Greetings, ma'am. Ma'am, can you
Hello.
please kindly explain C again?
C. Okay. All right.
Yes,
Not
please.
a problem. That's fine. Okay. So what I did here is I used reduction formulae. So let me just slip in an extra line up at the top. So for the 105, I said 180 minus 75. Okay, which is why it reduces to sine 75. Does that make sense?
Mm-hmm.
Okay, and then for cos 255, that's 180 plus 75. Does that make sense?
Yes.
Okay, so 180 plus is quadrant 3. So that's why it reduces to negative cos 75 because it's in quadrant 3.
Okay.
Okay, then in the next line, what you've essentially got is you've got a negative value, sorry, a positive value multiplied by a negative value. So when we multiply a positive and a negative together, we get a negative. So that's why there's a negative at the front here. And then I've just written the rest of it down. Okay, so 2 sine 75 cos 75.
Mm-hmm.
Okay, now 2 sine 75 cos 75 is a sine double angle. So double 75 is 150, isn't it?
Yes.
Okay, so that's why it becomes sine 150, but it's negative. Okay, because of the negative from the line above. So then
Mm-hmm.
again, I use reduction formulae. So for 150, which is in the second quadrant, I would use 180 minus 30. So that's going to reduce to sine 30, but it's negative because of the negative from above. Okay, and then I'm going to go and use my special angles and go and sub in, remembering my sign. Okay,
Thank you, ma'am.
no problem. All right, let's see what you guys are saying in the chat. Lisa, okay, please explain. E again, and I see Tlokomelo, you've also got a hand up. Okay, so let me just do E again. And what I'm going to do is I'll just rub that out and I'll just work through it again. Okay, so Lisa, there's no identity here. It's not a cosine double angle, it's not a sine double angle. So there's no identity to use with this particular question. So the only thing that you can do is go ahead and go and sub in your special angles. So the sine of 30 is equal to 1 over 2, but your ratio is squared. So sine squared 30 means a half squared. All right, so doing BODMAS, you'd square this first. So 1 times 1 is 1 and 2 times 2 is 4. Still following BODMAS because we always have to do BODMAS. 4 times a quarter would give us 1, but it's negative. And that's why we would end up as 0 as an answer. Okay, so Tlokomelo, I think you had your hand up first. Then in Kazimulo, you can ask after that. That's fine. Tlokomelo, do you want to ask?
No, ma'am. I fully understand E now. What I
Okay.
did after 1 minus 4 sine squared 30, I said cos, and then I opened the bracket and I said 4 times the 30 in the bracket. But I understand that it's no longer a compound.
Okay. All right. Okay. All right. That's fine.
Yes,
Perfect.
thank you, ma'am.
Okay. It's a pleasure. And then who was it? Nkazi. Okay. Nkazi, go for it.
Ma'am, by G, how do you get to negative 1045?
By G.
Yes,
Oh,
ma'am.
how do I? Oh, so are you asking how do I get negative tan 45?
Yes, ma'am.
Oh, okay. So that's 180 minus 180 minus 45
Oh,
is
okay.
135. And because tan is negative in the second quadrant, that's why it would be negative tan 45. Does that make sense to you?
Yes, ma'am.
Okay. All right. Yeah. So then after you'd got your -1, you'd bring down your 2 cos squared 15. Then when you bring the 2 cos squared 15 to the front and put the -1 at the back, you see that it's a cosine double angle. So that's why it becomes the cos of 30. And then the cos of 30 is a special angle. And we get √3/2. So you can see here, guys, when you were doing these calculations without the use of a calculator, if things don't cancel, then we are definitely using our special angles. Okay, Sinclair, go for it.
Sorry, ma'am. Could you please repeat the part where you with -1? How do we get there, ma'am? Like here, -1 plus 2 cos 15. Do you make it as a special angle? Because I didn't convert it there, ma'am. I just said negative tan 45 plus cos 30. Then I said -1 plus √3/2.
Oh, okay. So now the thing is that what you are doing is that you're using, because remember your cosine double angle becomes 2 terms. So if you've got cos 2a, you'd write it as 2 cos squared a minus 1. So what was 1 term is now 2 terms. So you can't use the -1 in your calculation because it's part of the cosine double angle. Okay, so this entire thing here, these two terms together become cos 30. Does that make sense to you?
Yes, ma'am.
Okay, so you can't write 2 cos squared 15 as the cos of 30 and then bring down the -1, because 2 cos squared 15 minus 1 is cos 30. Does that make sense?
Yes, ma'am. Thank you.
Okay, all right, no problem. Yeah, so you need to be careful because in here you could bring the 1 down. Here you can't. Okay, so you've just got to be careful what forms part of your identity and what doesn't. Okay. All right, so that was the homework. Well done, everybody, for giving that a try. Are there any questions about it before we move on? Going to start the next thing now. Are we all good? Okay, well, I'll take your silence to mean that everything is all right. Okay, brilliant. Okay, so today's lesson, good. Okay, I'm just sort of reading your messages in the chat. All right, that's fine. Faheen, you want to ask one last question? Go for it.
I think Fahim was trying to connect audio, but I haven't seen.
Okay.
Yeah, I think she's still not connected, but she should know what to do. Yeah,
Oh, okay.
could be
All right.
network in her case. Yeah.
Okay, all right. So I'm going to go on with Pythagoras. If we get a chance at the end, I'm going to come back and do this question with you. But I just wanted to go through the Pythagoras question. So now, essentially, we're at that point where we have learned all the new work. We've learned about compound angles. We've learned about double angles. From this point onwards, we now start the application of these in the types of questions that we get. All right. So one of the very common types of questions that gets asked in Trig is a question about the theorem of Pythagoras. Okay, so it's these sorts of questions that say if tan theta or sine theta or cos theta equals a value, and then they give you a restriction on the size of theta, calculate without the use of a calculator and with the aid of a diagram the value of, and then they give us various different things. So this is a typical sort of exam type question. So yeah, this is very important that we're able to understand and do these, because once we have sort of gone through all of the trig and whatever, we'll go back and we'll have a look at the exam type questions that they ask us. And this is one that often comes up, and it would be considered a sort of level 2 kind of question. So we would all want to be able to do this. All right, so just to refresh our memories, all right, when they say to us, if tan theta equals 3/4, how do we interpret that? What are they trying to say when they tell us that tan theta equals 3/4? What does that mean? Can anybody tell me?
Iyathetha andazi ke ngoku. Hey. Yo,
Please,
Jesus.
sorry.
Can we all please mute? I've muted everyone now, Teacher Ali. Please unmute on
you.
your side.
Yeah, I have done so. I think maybe we just need to send a private message there and just say language and yeah,
And
whatever.
everything else. Yeah,
Yes.
thank you.
Okay, all right. So you're on, somebody put something, we're using Sokotoa. Yes, we are using Sokotoa Nolwazi, but we need to use the correct version of Sokotoa. So Sokotoa is what we used when we were in grade 10. When we get to grade 11, we want to be working in terms of X, Y, and R. Okay, so Sokotoa becomes S, Y, R, C, X, R, T, yx. Okay, so what this means is that sine theta is y over r, cos theta is x over r, and tan theta is y over x. Okay, what do x and y represent? X and y are what? They are coordinates on the Cartesian plane. Okay, because remember, your terminal arm is anchored at the origin and it swings about the origin in an anti-clockwise direction when angles get bigger. So x and y are the coordinates at the end of the terminal arm. Right, so x and y are coordinates. Okay, so they change sign depending on which quadrant we are in. Okay, so x and y coordinates. What does r represent? R is? Does anybody know what R represents? It's the hypotenuse or the length of the terminal arm. Okay, absolutely. Okay, so it is the length of the terminal arm. It is also the hypotenuse. That's why R is always positive, because it's a distance. Okay, so R is always positive. X and Y change sign depending which quadrant we are in. Okay, so our signs are very, very important when it comes to X and Y. All right, whenever they ask you to calculate R, it's always going to be positive because it is a distance. There we go. Okay, so Lisa's already putting up answers for us. That's really nice, Lisa. Thank you so much. What I was trying to get at here at the beginning is that 3 over 4, these are coordinates, right? This is y over x. Okay, so that's how we interpret tan theta is 3 over 4. We understand this to mean that x is 4 and y is 3. But, there's a big but, and I'm going to come back to this now, right? They're telling us that angle theta, so the angle over here and this angle are the same. Angle theta is between 180 and 360. So tan theta is positive. So looking at our cast diagram, we see that tan theta is positive. It's 3 over 4. So it would be positive in quadrant 3 or in quadrant 1. But now they tell us that our angle is between 180 and 360. So here's 180 and here's 360 if the terminal arm is swinging in an anti-clockwise direction. So if the angle is between 180 and 360, either it's in quadrant 3 or in quadrant 4. But tan theta is positive, so it has to be in quadrant 3. That's how we determine which quadrant we are working in. Okay, so these two pieces of information work together to tell us which quadrant we are working in. The sign of our ratio together with the size of the angle, right? So now when they want you to draw a diagram, they want you to draw a diagram of the Cartesian plane. Here's your terminal arm anchored at the origin, and it's come to rest in quadrant 3. There at the end are our coordinates. Now, this is why I was saying but. What are the signs of X and Y in the third quadrant? Exactly, Sharon. Okay, so that means that this is -4. Okay, our x coordinate is -4 and our y coordinate is -3. So I've got to be very careful because both x and y are negative in the third quadrant. All right, and this is angle theta over here, like that. And that is how you should draw your diagram. You should label the angle, and then you should also draw a point at the end of the terminal arm and put in your coordinates. R is the length of the terminal arm. Okay, so that's what's missing in this case. And this is why we call these questions Pythagoras questions, because we now need to use the theorem of Pythagoras to calculate the length of R. All right, so we're going to use x squared plus y squared equals r squared. So now we're going to substitute in. X is -4. Y is -3. So that means that we're going to end up with r squared being equal to 25. Okay, normally if I was solving for X or for Y, I would consider either a positive or a negative answer, depending on which quadrant I'm in. But because I'm solving for R and R is a length, it is a distance, R is always positive, R is only going to be equal to 5 and not to -5. So if you have a look in the chat, I think it was Lisa. There we go. So Lisa's got all the correct answers. Okay, X is -4, Y is -3, and R is equal to 5. Okay,
Well
so the
done, Miss
biggest thing,
Lau.
yeah, well done, Lisa. That's really, really good. Okay, you obviously switched on and wide awake this afternoon. So that's absolutely brilliant. Okay, so be very, very, very careful of your signs, matrix. That is where we end up falling down in this particular section, is when it comes to our signs. Then I like to do what Lisa's done. I like to make myself a summary of what my X, my Y, and my R are before I start answering the questions. Okay, so we've got to do all of this work before we're actually ready to begin the question. Cool. No problem, Lisa. All right, so Onwaba says, ma'am, are we wrong if we draw a right angle triangle on the Cartesian plane? No, you're not wrong when you do that. But the thing is that a lot of the time you guys end up connecting the end point to the wrong place. All right, so it's not necessary for you to draw a right angle triangle. What is important is that you've drawn the terminal arm and you've labeled the angle and you've labeled it. If you were to draw a right angle triangle, it would make a right angle with the y-axis. Okay, it's not wrong, it's just not necessary. Okay. All right, so now let's go and have a look at the questions. All right, so now we are applying our double angles. All right, the first one that they give us is sine 2 theta in A. All right, so what we would do now is obviously write that down. And now we've got to go and substitute. Before we can substitute, we're not working in terms of 2 theta, we're working in terms of theta. So what do you think we need to do to sine 2 theta before we can go and sub in? Think about your formulae. I'm going to go and grab, where is it? This is our last lesson. Oh, there it is. Just grab that quickly. Sorry, I should have put it here. I'll just stick it there for now. There you go. What are you going to do with sine 2 theta, guys? We're going to write it as exactly. We're going to write it as 2 sine theta cos theta. So I'm just going to move it out the way. We're going to expand it and we write it as 2 sine theta cos theta. So this means 2 times sine theta is y over r. That's why we need to know SYR, CXR, TYX. Okay, so sine theta is y over r. Y in this case is -3 and r is equal to 5 multiplied by cos theta. Cos theta is x over r, so that's -4 over +5. Okay, and now we're going to multiply. So 2 times -3 times -4 would give us +24, and 1 times 5 would leave us with 25 in the denominator. Okay, so Cynthia, I saw you put your hand up. Do you want to ask a question?
No, ma'am, I'm good.
Okay,
Those
you're
was
all good. Okay, all right, well done. Okay, so now let's go and have a look at what the next question was. It was cos 2 theta. right? So now here, according to our summary of double angle formulae, we've got 3 options. When you are doing a question on Pythagoras, it does not matter which one you use. Okay, you can use any one of the 3. It does not matter in Pythagoras. Okay, but it is going to start mattering when you start doing identities and equations, which one of the cosine double angle formulae you use, because there are specific ones that get used in specific situations, but I will explain that when we get there. But when you are doing the theorem of Pythagoras, it does not matter which one you use. Okay, I don't know why. I just seem to have a preference for 2 cos squared theta minus 1. But it really doesn't matter which one of them you decide to use. So I'm just going to stick that out of the way. You do not have to do all 3. Okay, so when it comes to part B, they wanted cos 2 theta. So I'm choosing to write that as 2 cos squared theta minus 1. Remember, we had said that cos theta was equal to minus 4 over 5. But cos squared theta, so your ratio is squared minus 1. Okay, and again, now you'd have to follow the order of BODMAS. We'd have to square first, then multiply, and then minus 1. Okay, so this leaves us with 16 over 25, take away 1. And that would leave us with 32 over 25 minus 1. And our final answer would end up being 7 over 25, if my maths is correct. Just double check myself. Yes, there we go. Okay. How does question B feel? Is it making sense, Matrix? Is everybody okay? Are there any questions? Cool. All right, good. That's positive. Nice, Lisa. Thank you. Thanks, Nolwazi, Nobasutu. Tlokomelo. Tato, you feeling good? Batibile, you okay? Anati. Sibongenhle. Sharon. Siamtanda, all good. Okay. Bochepo, lovely. Onako, okay, you also good. Angelique, you happy? All right, cool. Anwaba, Sivanati. That's really encouraging. Well done, Matrix. Okay, very, very good. Well done. All right, and then the last question that they gave us for question C was tan 2 theta. Okay, so let's just talk a little bit about tan 2 theta. What I'm going to do is I'm just going to scooch over to the side. So what did I do? There we go. Hold on, just clicked on the wrong thing. Okay, so when it comes to tan theta, recall from grade 11, the tan theta is also an identity. Okay, it's one of our grade 11 identities, and we call it the tan identity, and it is equal to sine theta over cos theta. Right, so a lot of the time when we see tan theta, we rewrite it as sine theta over cos theta. So this also applies if it's squared. So if you've got tan squared theta, you would write it as sine squared theta over cos squared theta. And if you had tan 2 theta, you'd write it as sine 2 theta over cos 2 theta. Okay, so bear that in mind going forward as well. Okay, so in this question where they give us tan 2 theta, we will rewrite this as sine 2 theta over cos 2 theta. Now, something else I just want to say before I move on, okay? You need to be very, very careful, Matrix, when you are writing your cosine double angles, because it's very easy for the square to end up looking like a 2 and vice versa. Okay, so make sure if you're writing a 2 as an exponent, that it is clear and obvious that it is an exponent. If you're writing a double angle, make sure that it's clear and obvious that that 2 is part of a double angle and it's not a square. Okay, so just be very, very careful of that, because often in tests and exams, these things kind of tend to blur a little bit. All right, and then what we would do is, as always, is we would substitute in. So, sorry, expand and then sub in. So sine 2 theta, we can only write it as 2 sine theta cos theta. And here cos 2 theta, I'm going to write that as 2 cos squared theta minus 1, and then we would go and sub it. Now, the thing is with this particular question, we already know what sine 2 theta is equal to, and we also know what cos 2 theta is equal to. All right, so I'm going to cheat, and instead of recalculating it, well, it's not cheating. I'm just going to use my answer from A. So I know that sine 2 theta, or 2 sine theta cos theta, is 24 over 25. And then I want to divide that by cos 2 theta, which I know is 7 over 25. Okay, and then recall from grade 8, when you are dividing fractions, you have to tip and times, or keep, flip, change, depending on what your teachers taught you. So 24 over 25 stays as is. We change the divide to a times. We put the 25 at the top and the 7 at the bottom. Okay, and then we can say 25 goes into itself once, and that leaves us with 24 over 7 as our final answer. Okay. Yeah, that's it, Lisa. Well done. You're really good at these. Good job, Lisa. Nice. And Nhlanhla, you raised your hand. You're welcome to unmute and speak.
Afternoon, ma'am.
Afternoon, Nhlanhla.
Ma'am, I have a question for A. You
Sure.
said on the second step, you said 2 times -3 over 5. Ma'am, why did you leave out the sign, ma'am? Why is it not included? And for the cost too on the...
Okay, so what you're asking there is a very common mistake that is made by high school students throughout the world when it comes to trigonometry. And what you are doing there is you are confusing calculating an angle with writing a ratio. All right, sine theta is a ratio. Sine theta is y over r. I'm not calculating the size of theta. So I'm not going to write the word sine down. I'm not using the ratio to calculate the size of the angle. Sine theta is -3 over 5.
Okay, thank you very much.
Okay, it's a very, very, very common mistake. Very, very common. A lot of people do it. Okay.
Thank you, ma'am.
No problem. All right, Sharon, you've also got a hand up. Go for it.
Ma'am, please explain C, like by is it the last step, I think?
Okay, so
Yes.
so what I've got here is 24 over 25 divided by 7 over 25. So I'm dividing fractions. So the rule when you're dividing fractions is to multiply by the reciprocal. So that's why I'm changing the divide into a times, and then I'm putting the 25 at the top and the 7 at the bottom, because that's how you divide fractions.
Okay.
Okay, so then it's multiplying top with top and bottom with bottom, because that's how we multiply fractions together.
Oh, okay.
Okay, so
Thank you.
so I cancel down the 25 at the top with the 25 at the bottom. So I've got 24 times 1 in the numerator, which is 24, and 1 times 7 in the bottom, which is where 7 comes from.
Okay, ma'am.
Okay, no problem. Zinhle?
Ma'am, I was going to ask for B, if we had used a different identity, if, like for example, sine squared theta times cos squared theta, would it have given us a different answer?
Okay, Zintle, you can't use sine squared theta times cos squared theta. You've got to use one of the cosine double angle formulae. So you can use any one of these three here. So you can either say cos squared theta minus sine squared theta, or I used 2 cos squared theta minus 1, or you could have used 1 minus 2 sine squared theta. And no, none of them, if used correctly, would give you a wrong answer. It would all give you the same answer. Okay,
Yes,
does that answer your question?
yes, ma'am. Thank you.
All right, no problem. Okay, so now that means that you guys are hopefully ready to answer a question just like this on your own. Okay, let's see. Right, so there's your question. Let me grab that and bring that down for you so that you've got it right here. There you go. There's your formulae. Okay, so this one is for you. It's almost identical to the previous one. There's just one extra step involved. You've got to divide both sides by 3. So let's just help get you started, but theoretically you should know that. So if you've got 3 cos theta equals root 5, you would divide by 3 on both sides, and cos theta would be equal to root 5 over 3. Okay, so now I'm going to let you do the rest on your own. You've got to draw your diagram. You've got to solve for a missing letter using Pythagoras, and then you can start answering the questions. Okay, Matrix, off you go. And then, yeah, please reach out to either Yolanda or I if you need help.
Yep. Let's go, guys. But we
Yeah,
have
this is
in
going to,
front of us. So.
yes.
We can do this. We got it. Let's go, Fahim. Amanda, that's okay. We hope you get better soon. Speed recovery to you, Amanda.
No worries, Amanda. Just do what you can, okay?
Fahim is still not connected to audio. I wonder if she can hear us. Does not
I
make sense.
wonder. Normally Fahim doesn't struggle with that, so I don't know why.
not struggle at all.
It's not, yeah, it's not working today.
I'm sure it's network, or maybe let me just check up on her privately.
Okay, cool. Thank you.
Onwaba,
Oh, wow.
Doi, you'll be okay.
Lisa's,
Sorry, Teacher Lee. You
it's
can-
okay. Lisa's done and Nobasutu's done.
Yeah, they're getting the. I wonder, did
They
you do
are.
A or did you do A until C?
Yeah, did you do A through to C? Okay, so after you've drawn the diagram and you've
Oh,
calculated the missing letter, you've still got to do A, B, and C. Okay, all three.
wow,
Sibongentle says. Nobasutu says all three. Okay,
well
good
done, guys.
stuff.
And Doi, I saw that you said that you're struggling. When we do correction, you can pay much more attention, but also we can help you if you let me know, you know exactly where do you struggle, then I'll be able to help you. But I'm sure we'll do corrections and Teacher Lee will explain to you.
I will indeed.
Wow.
What
I'm
he's also
so
done all three.
sure. Well done, guys.
Yeah, absolutely. So I'm just going to wait another couple of minutes to just give people an opportunity, and then we're going to go through the corrections. Okay, Tina's done, Onako's done. Beatrice is done. Okay, good stuff. Well done, everybody. Okay, so let's go through the answers. All right, is anybody feeling brave enough to tell me which quadrant they thought we were working in? Which quadrant are we working in? Okay, Zintle, go for it. Which quadrant did you think we were working in?
Quadrant 4, ma'am.
Quadrant 4. Okay, and what made you come to that conclusion, Zintle?
Because cos is positive in quadrant 1 and 4, but
Uh-huh.
the restrictions were given was 180 and 360, which is in quadrant 4.
Absolutely, well done. Okay, so you would have drawn your diagram like that. There's your angle theta. You're quite right. You are working in quadrant 4. So what value? So let me say, so here at your end point over here, what do you have and what's missing? What's missing at the end point? Root 5 is our x. 3 is our r. So what's missing, Matrix? The y value. That's quite right, Tato. The y value is missing. And we know the length of the terminal arm. It's 3. Okay, so Tato, when you calculated y, what did you calculate y to be? If you're too shy to talk, you're welcome to put it in the chat. What did you get, Tato? Tato says y is 2. Okay, so let's just have a look at that. So when we square the square root of 5, we would get 5 plus y squared is equal to 9. So we got y squared is equal to 4. So I can understand why you would have said y is equal to 2. But what is the problem with your answer, Tato? Just one small, there we go. Sibongenhle's got it. Okay, so don't forget, Tato, you are in the fourth quadrant where x is positive and y is negative. What you can do when you write it like this is you can say plus minus the square root of 4, and perhaps writing it like this before, as I'm highlighting in turquoise, before you actually write down your answer, will just help you to remember about your signs. Okay, so y has to be equal to -2. Okay, very good. Well done, everyone. All right, so in pink on the side, we've got x is positive root 5, y is -2 because we're in quadrant number 4, and r is equal to 3 in this case. So now that we've got this information, we are now ready to start answering our questions. So the first question was the value of sine 2 theta. Okay, so we would have said sine 2 theta. We'll get a mark for writing 2 sine theta cos theta. Sorry, I shouldn't do this. Let me rather refer this to somebody who's feeling brave and wants to tell me what they wrote here. Sharon, go for it.
Ma'am, I had said 2 multiplied by -2/3.
Cool, keep going.
Multiplied by √5/3.
Lovely, Sharon, that's great. And what was your final answer?
-4 √5/9.
Beautiful. Well done, Sharon. Excellent, excellent, excellent. Well done. That's really, really good. Brilliant. Perfect, 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 perfect. Okay, so if you also, like Sharon, got -4 times √5/9, you also got the correct answer. So that is brilliant. Lisa, your hand is up. Do you want to do the next one, Lisa? Lisa, you're welcome to unmute and speak if you want to. Go for it.
Okay, I wrote B. Okay, cos 2 theta
Mm-hmm.
is equal to 2 cos squared theta minus 1
Mm-hmm.
equal to 2 open brackets √5/3 close brackets squared minus 1
Fantastic. Keep going.
is equal to 1/9.
Is equal to, so you got 1/9 as your final answer. Okay, so I'm just going to put that over there. All right, so here we would have said 2 times, and that would have been 5/9 minus 1, and that would give us, yes, there we go, perfect. You're quite right, it is 1/9. Okay, lovely. Lisa, that's excellent. Well done. Mikhail, you want to do C? Excellent. Go for it. Let's do C as well. Mikhail, go for it.
Good day, ma'am.
Good day.
So C is tan 2 theta is equal to sine 2 theta divided by cos 2 theta.
Lovely.
2 sine theta cos theta
Mm-hmm.
divide divided by 2 cos squared theta minus 1.
Lovely.
Then it's negative 4 root 5 over 9 divided by 1 over 9. Then I swap the my sign. So it's negative 4 root 5 divided by 9
Mm-hmm.
multiply by 9 over 1.
Excellent.
My answer is negative 4 root 5.
It certainly is, Mikhail. That is brilliant. Well done. Well done, guys. Oh, Matrix, that's wonderful. I feel so happy. Mikhail and just trying to remember who else gave us answers. Lisa. I can't remember who did the first one. Was it you, Zintle?
Sharon or
Sharon. Sorry, Sharon. That's wonderful work. Well done. Okay, really, really, really good, Sibongentle. That's great. You got all 3 of them correct. Good stuff. Very encouraging indeed. Okay, any questions before me too? Good, Sharon. Well done. Mikhail, me too. Lovely. Good. Wonderful, wonderful.
I wonder if anyone had some struggle a little bit.
They all seem to be saying,
Yeah, they all got it correct. Wow, guys.
That's very, very positive. Well done. Well done. Well done. Okay, so we've only got a few minutes left. This question is very similar, but there is something that's a little bit different. And this is something that I would like to discuss with you, but I think it's better for me to do this at the beginning of a lesson rather than at the end. So what I'm going to do is let's do part A and part B. The real reason that we're doing this question is actually because of question C. It's not because of anything else. So there's something here that I want to show you. So let's do A and B, and then we'll worry about doing question C the next time I see you. I'll put this question up again and I'll just remind you, and then we can do that before we jump into ratio in terms of a letter. Okay, so this question is very similar to the previous ones. I just want you to try A and B. Let's see how that goes. We've got about 5 minutes until we need to say goodbye, so we're under a little bit of pressure here just to get this done. So let's see if we can get this done as fast as possible before we say goodbye. Oh, Yolanda, I've just discovered there's load shedding at 6 o'clock.
Oh, okay. No, don't
Okay,
worry.
for me, so yeah, we're just going to have to switch our battery round. So if I am a little bit late getting started,
Okay, no, that's
you'll just
fine.
have to forgive me, okay?
So the other class when the time arrives.
Yes. Yeah, so my power's going off in like 7 or 8 minutes.
Okay.
Okay.
one who has done then with A and B, or are you gonna do corrections with us, Teacher Lee?
Well, I don't think we're gonna have time to do corrections.
Oh.
So hopefully everybody's got a sort of little head start on me, and I'm gonna do that.
Okay.
And hopefully everybody's writing the same thing that I am. All right, so this question is, sorry, the terminal arm has come to rest in quadrant number 2, where sine 2 theta or 2a is positive, and 2a is an angle between 90 and 270. So quadrant 2 is where it has to be. Hopefully everybody's got that. You've realized that it's x that's missing. And then when it comes to calculating the value of x, you would have used the theorem of Pythagoras. And what do you need to be super, super careful of here, Matrix? Signs, absolutely. Sibongenhle, the sign, yes, Tanda. So when we solve for x, is x going to be positive or negative? Yes, Nolwazi, x is negative. Okay, so x will be equal to -2. All right, hopefully all of you are at that point as well. Good. All right, so just very quickly, question A. Cos 2a, your angle is 2a, you're working with 2a here. So cos 2a is going to be -2 over 3. Okay, remember your angle is 2a. All right, then when you do the second part, part B, you've got tan 2a, and here you would have y over x. It would be negative. So you would have √5 over -2. And hopefully those are the answers that you got here. Yes. Oh, good. All right. So people are saying, yes, that's wonderful. Well done, Matrix. Good. Well done, Nolwazi. Well done, Nobasutu. Well done, Kamchelo and Nolwazi and Sharon and Siam Tanda. Good. Sibon Gentle's got fire going. Lisa's happy. Omoholo, Anati, Nhloso, Amu. Good, well done. Okay, and as I said to you guys, I'm going to leave it there. Unfortunately, we've run out of time now, but I will do question C with you next time because this is something that comes up. It's a little bit more difficult, but I want to show you this because it is something that you are going to see. Okay, all right.